Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, wonderful dear students of Senior 1. I just want to welcome you once again. I'm here, your chemistry teacher, and we'll be looking at unit number 11, which is acids, bases, and the pH. And we are on lesson number 2, applications and dangers associated with acids and bases. I just want to invite you to urge you to get ready and be at par with your notebooks and pen as we continue together with our lesson. I just want to go through a review of what we are talking about, and I just want to start with the standard pH color chart. So this works together with the pH scale. So this is a chart. It is indicating the colors corresponding to the acidity, to the alkalinity, or the neutrality of different solutions. So when you look at this, it also indicates the pH scale, because the pH scale has values ranging from 0. When you look at your screen over there, you will be able to see that the values here, they are ranging from 0 and you move up to 14. So the 14 is the last value. So the 14, that is the highest pH. And that means the solution is highly basic. And 0, the solution is highly acidic. So as you're moving from this point of neutral here and move in this direction there, you are increasing the acidity of the solution. Going to the right of your screen, you'll see you are moving from neutral, moving that side. So when you are moving in that direction, in the right direction, starting from the neutral point, then you are increasing in the basicity of the solution or alkaline. So it has these two parts. You have the acidic part over here, and then you have the alkaline part, or the basic part. So in the middle here, we have the neutral point, which is the 7. So that neutral point indicates that the substance is neither acidic nor basic. So when you're moving towards 0 on your left from 7, that is increase in the acidity. Moving from 7 towards 14, you are increasing the pH, and that means you are increasing the alkalinity of the solution. What am I trying to say here? If the solution has a pH of 13, for instance, and another solution has a pH of 9, so the one with the pH of 13 is more basic, is more alkaline than the one of pH 9. The same, likewise, if I have a solution of pH 5 and another one of pH 2, it means the one of pH 2 is more acidic than the one of pH 5. So that is the information that we need to get from the pH scale and the corresponding colors. So the colors correspond to according to the pH scale, they will also correspond to the nature of the solution. When you are moving towards your left on the screen, you will see that the solution, the colors are moving from greenish to yellow, orange, reddish brown, then to deep red. So what does that mean? It means the solution is becoming more acidic with the red color, and is moving from the neutral towards your right. That is from 7 up to 14. You see the color changes from green, then to pale blue, pink, purple, and then deep blue. So those are the colors that correspond with the nature of the solution and corresponding with on the pH scale. So it is also used to measure the pH or the acidity or the alkalinity of the solution. So we have mentioned that if the pH is 7, the solution is neutral, neither acidic nor basic. So if it has a pH that is above 7, then the solution is alkaline or basic. If it is below 7, that is ranging from 0 to 7, that solution will be acidic. And we also have the pH meters. So with the pH meters, I said we have a number of them. These are the few that I was able to come up with, but there are a number of pH meters, different pH meters that are used to measure the nature of the solution, used to measure whether the solution is acidic or basic. And there are a number of them. The most common one is this one that you see in red, or rather in orange. So this is the one which looks like a pen. So this part over here is inserted, you insert it into the solution, and the value that corresponds to the pH will be read on this part here. So that is, you'll see 0, 0. That indicates that if the solution, if that pH meter is inserted into the solution, then it will be able to measure the pH, indicating the value whether it is 3, that if it is 3, 7, 8, but the values have to range from 1, have to range from 0 up to 14. That is very important to note. And between 0 and 7, we said that is acidic. Between 7 and 14, that is basic, which also varies depending on the value. So we have other meters over on the screen. You see we have this one. When you look at the screen of this meter, you'll see it is measuring 3.78. So that means that solution that is in the flask over here is acidic. And then we have these ones, we have another one of this type, where you have the solution here with this reference electrode with the probe inserted into the solution, and then the information is read on the screen. The information read on the screen will correspond to the pH of the solution. And these are some few that I've been able to come up with, but there are a number of them. They also measure the nature, the basic, the basicity or the alkalinity of the substances in the laboratory or in industries. So we just want to move on and then look at the applications, uses of acids and bases. Are these acids important in our daily life? Yes, of course they are. So here, when you look at the screen over there, there are a number of, so we have the acids, over here, we have the acids over here, and then we have the bases over here. But what is important here is that these substances, of course, when you look at this one is like the stomach. So we have acids in the stomach. So we have lemons ranging from here. So there must be acids with the pH of 2 in lemons. Then we have grapes. When you go to the grapes, then you have, the grapes have substances, they have acids which with the pH of 3. We have tomatoes. The tomatoes have also have acids ranging for the pH of 4. We have bananas. Can you believe even in bananas they are also acids because they are also fruits, of course. Then they have a pH. So the acids there correspond to the pH of 5. And then we have milk. The milk has also acids. We have pure water, which is neutral, of course. In the pure water, you won't find there anything as far as the acid or basic is concerned. Then we have eggs. The eggs contain bases. Then we have baking soda. If you make the bread and so on and so forth, then you know what we mean by the baking soda or baking powder. Then we have soaps, we have ammonia, we have bleaches that we use for that are used for cleaning and mopping different places, and so on and so forth. So these are substances that we have, that we meet in our daily life. And these are some of the applications now that is actually put in summary. So we can be able to tell from this information that we have that these acids and bases are very, very important. So it is very important to note that those substances can either be part of our bodies or they are substances that we find in our daily life. So let's go on and look at some of the applications of these bases. Specific, let's be specific. Ammonia solution as an example. Ammonia as an example. So ammonia is a base, and it is used in manufacture of fertilizers. Ammonium sulfate, we have ammonium sulfate. Ammonium sulfate. This is the symbol for the ammonium sulfate. This is one of the artificial fertilizers, ammonium sulfate. We have ammonium nitrate. Ammonium nitrate. Also artificial fertilizers, ammonium nitrate, and so on, ammonium phosphate, and so on and so forth. So these are some of the examples that are used as fertilizers. Why do we have to use fertilizers? Of course, we need to increase the productivity of the soil, and as a result, the productivity of the crops, and the results of the high yields. Sodium hydroxide in the manufacture of soaps and detergents. This is very common. If you are using the soap, everyone uses the soap. Everyone uses detergents. So sodium hydroxide is the main component as far as the manufacture of the soap is concerned, because oils combine with the sodium hydroxide to form the soap, and plus an alcohol. So the alcohol is also formed. So this is another simple example showing that soaps are formed from sodium hydroxide. So it is a major raw material of as far as the soap is concerned. That is sodium hydroxide, which is a base. Ammonium hydroxide is also used as a cleaning agent in laundry work. So what it does is to reduce the hardness of water. Later on, we'll talk about the hardness of water. We have different types of waters, and those waters are explained, or they are determined, they are described in terms of hardness. In terms of hardness, that how much of the ions are present in those ions, or rather in the water. So the laundry work for the ammonium hydroxide or ammonia solution. Magnesium hydroxide is used in the treatment of indigestion. We are going to discuss this in details later on. Calcium hydroxide is used as a garden lime to reduce soil acidity and in the manufacture of cement and toothpaste. So the toothpaste contains some calcium hydroxide. Why? Because we said as you eat, the glucose, the foods containing starch, will be producing some acids that stick into our teeth. And therefore, we need some other substances that can neutralize those acids. And sodium calcium hydroxide is one of them that can be. So that is why it is put into the toothpaste. Soil acidity, some of the soils may not actually be good for certain plants. They may be acidic or they may be basic. So we have lime, and we are even blessed that we have this lime. We don't need to get it from outside the country. When you go to Musanze, you go to Karongi, you go to Rusizi, there is a lot of lime, which we call ishwagara. So there is a lot of it. And this is used to reduce the acidity that can destroy the crops and accommodate some certain types of crops. Let's look at the applications of the acids. Hydrochloric acid is produced in our bodies to aid the process of digestion. Why is this hydrochloric? As we had mentioned earlier on, the hydrochloric acid that is produced in our bodies aiding the digestion. How? By killing the microorganisms. Those microorganisms that may be swallowed with food can be killed by this hydrochloric in the stomach. And it also provides the medium under which the enzymes are catalysts. that help in the digestion of the food, breaking down of the food. So they provide the medium under which these enzymes work, acid. So that is very important. When you go to the screen once again, you will find that sulfuric acid, which is found in car batteries, the car batteries are used to make the vehicles, the cars to move from one place to another. So if our vehicles don't have those car batteries, they may not be able to start and therefore move from one place to another. So our cars and our vehicles need these car batteries, and they contain sulfuric acid. It is also used in manufacturing the plastics, the pesticides, detergents, and other pharmaceutical products, like the drugs. One of the drugs that I can give is the aspirin. Aspirin itself is an acid. And even some fertilizers, an example can be ammonium sulfate. The ammonium sulfate is formed from ammonia combining with sulfuric acid. Ethanoic acid is another acid that is common, which is a major component of vinegar that is used for food seasoning. So when we talk about the ethanoic acid or vinegar, this is very common. And then food seasoning or food spicing, vinegar is used. And therefore it is used, one of the applications that we can look at. Carbonic acid is used in soft drinks to enhance the taste. When you open the soda, there is that gas that comes out. So it is carbon dioxide that is, when it mixes with water, so it forms the carbonic acid, and it enhances some taste of those drinks. Nitric acid is used in the manufacturing of the nitrogenous fertilizers, the explosives, manufacture of dyes and paints. The dyes that we may have, some of the dyes that we can talk about are actually indicators. If you remember yesterday in the previous lesson, we had talked about the indicators. These are organic substances that can be used to tell or to detect whether the substance is an acid or a base. And most of these indicators are colored. So they are colored substances. So that's why they can also be examples of the dyes. So dyes are colored substances. When you say the dye, that is the colored substances. You know the paints for buildings and windows and so many other places, that is, the acid is used. Phosphoric acid as an anti-rust pest and also in phosphate fertilizers. So when we have the phosphate, like ammonium phosphate, that means we are using sulfuric acid. So ammonium phosphate, when you say ammonium phosphate, so this one is the fertilizer that is formed from the combination of the sulfuric acid and the combination of the sulfuric acid, phosphoric acid, and the sulfate, and the ammonium phosphate. So here, this comes from two substances. So you have ammonia, and it is combining with phosphoric acid. So these two substances will combine to form that fertilizer. When you have ammonium sulfate, this one is coming from, you are having ammonia that is combining with the sulfuric acid to form this fertilizer. When you have ammonium sulfate, so in this case, you'll be having ammonia, which is combining with nitric acid. So these are the salts, but which are used as fertilizers. Methanoic acid is used in kettle descalers. So when you have the kettle, when you are boiling water, there are certain substances that accumulate, and they look like rust inside the kettle. So if you want, and those substances, when they accumulate in the kettle, so they are bad conductors of electricity. And for that reason, the water you are boiling takes longer. So that means you will now use more fuel and therefore be spending more money on electricity. So you need to clean the kettle, and cleaning that kettle, removing those substances, is using the methanoic acid. So it does that very well and removes them so that you reduce on the expenditure of the electricity. So the stomach indigestion, because I've mentioned that we'll talk about this one in detail. Hydrochloric acid in the stomach helps in the digestion of the food. However, when the stomach secretes excess of the acid, this is also very dangerous. When the acid is excess, then it causes indigestion. How? The acid burns the linings of the stomach because our stomach linings are the ones producing this acid. So when they are produced in excess, they may also attack the linings of the stomach and then causing the ulcers. However, there are some antacid tablets that contain mild bases. We call them milk of magnesia, that is magnesium hydroxide. That when you have that problem, you can either go to the hospital and they give you those magnesium hydroxide. It is a base. And what it does is only neutralizing the acid that has been produced. This excess acid, so the base, that pain or that is created may be relieved. Or you may get some relief when you take these antacid tablets because of the excess acid. If you don't take those antacid tablets, then the ulcers may continue, which may lead to either the stomach holes that may lead even to death because there will be no digestion when there are holes in the stomach. Right? We can just also talk about the soil pH. The soil plant's growth, the plant growth is affected by the acidity or the alkalinity of the soil. So the degree of the acidity depends on the concentration of hydrogen ions in the soil. So when the concentrations are very high, then the soil, we say the soil is pH, the pH of the soil is high. When the concentration of the hydrogen ions are low, then it is said to be acidic. So low pH corresponds with acidic. High pH corresponds with basic. So soil acidity is also affected by excess use of fertilizers and acid rain. So when you use excess fertilizers, so we know the fertilizers are very important, but we shouldn't use excess because they also have some negative effects on certain crops. And therefore, even the acid rain, when we are using these the fertilizers, because we have seen some of these fertilizers contain the acid. So the soils may become unsuitable for a particular crop or plant. If the soil is too acidic, for instance, it will be treated with lime. So I've mentioned that one, that we have a lot of lime, which is calcium hydroxide, calcium oxide, in areas of Musanze, in areas of Rusizi, in areas of Karongi. So you can get a lot of lime from there at a cheaper price if you want to increase the production of the crops that may be affected by the pH of the soil, and maybe the acids are too high, you need to reduce. Why is soil pH very important? So you need to know, if you are planting certain crops, you need to know which crops grow well in a certain or specific pH of the solution. That is why we have a number of crops over there. When you go to the screen, we'll be able to show that these are tomatoes. The tomatoes grow well in the pH ranging from 4.8 to 6.5. And when you look at the carrots, they are ranging from 5.5 to 7. And you look at the onions, 5.8 to 7. Lettuce, you have 6 to 7. You have cabbages ranging from 6.0 to 6 to 7.5. So it is very important to know the pH of the soil before even you plant the particular crop, because you may not get the best yield as a result of the pH of the soil that may affect, which could affect the yield of your plants. So this is just a simple summary from where we started from. We said some common acids in our daily life. It is also very important. That is why I want us to also go through. Ethanoic acid, we've said it is found in vinegar, tomato juice, and so on. Citric acid, it is in citrus fruits. That is oranges, lemons, grapes. And lactic acid in yogurt and milk, tartaric acid in grapes. You find tannic acid found in the tea. And what about those commonly found in our lab? In our labs, there are also acids that we find there. So we find there hydrochloric acid, sulfuric acid, nitric acid. And this, you remember we have mentioned that the sulfuric acid is found in our car batteries that are used to used for the starting of the vehicle. The dangers which are associated with this acid, we have the acid rain. We have this acid rain is very dangerous because when it forms, it will destroy some of the buildings that are made of cement and they're made of cement and clay, because those substances contain calcium carbonate. We also have to mention that this acid rain causes nutrients to be leached, so they get into the lower layers of the earth, and therefore crops may not be able to access the nutrients. So aluminium ions are freed as in form of aluminium sulfate, resulting into the damaged trees. So these are some of the crops that you can grow and the pH that can be. You see the grapes. We have also mentioned some of the pH ranges of these particular crops, and then you need to know that one as well. And pH in the environment, these are some of the dangers. Water, the aquatic organisms, if the pH in the water changes, some of the aquatic organisms may die, and therefore you may not be able to, those organisms may not be able to survive in the water. So it is very important, and we have mentioned that even excess acid produced in our stomach, though it helps the digestion, it can also destroy the stomach. So these are some of the acids. You can also even be able to look at just a simple research and continue and finish up and look at other dangers associated with acids. Dear students, I hope we have been together. Thank you so much. Hope to see you in the next lesson. Bye-bye.